Hey everybody, me and Mr. Sansoni just took a short trip out here to Brussels to visit the Atom here. Pretty sweet, right?
It is super sweet.
Plane ride was just like that, blink of an eye.
Super fast.
Okay?
Speed of light.
Right. So we're going to take a look at what an isotope is and what atomic mass is today. Okay, two things that we probably have not talked about yet, or maybe you don't even know about. Okay, so before we even get there, let's just talk about an atom in general. All right. So atoms are neutral. Do you know what that means?
Me?
Yeah.
They have no charge.
Okay, right. Okay, and they have no charge because why?
They have the same amount of positives and negatives.
Absolutely. Do you know what those positives are called?
Protons.
Very good. And our negatives are going to be?
Negatrons.
Really close. Okay, we're going to call those electrons. All right, so when we have the same amount of protons and electrons, we become neutral because they cancel each other out.
Perfect.
Okay, and that's an atom. All atoms are neutral. Protons equal the electrons. Okay? Then we have an ion. We've already talked about those, and those are charged. Okay? And now, if an atom is neutral, because the protons and electrons are equal, how do you think we become charged?
They're not equal.
Oh, look at this. A student right here. Okay? So, in the case of an ion, we have either more or less electrons. They are no longer equal to the amount of protons that we have.
Okay.
All right? If I have more electrons, I'm going to be what charge do you think? Since electrons are negative.
They'll be negative.
Oh, very good. Okay, if I have less electrons, I'm probably going to be
positive.
Very good. All right. So, for example, I put the chlorine atom on here and a chlorine ion. So you can see that the proton number never, ever, ever, ever changes. Okay, kind of like student ID numbers; those don't change.
What if we change the proton number?
Then we change the element.
Oh.
So if we change proton number, we are now something different. So, like if I typed in the computer and I looked up your student ID number and put 17, and it popped up me. Okay, if I change it to 18, it would pop up you. Two different things. Okay, so kind of like everyone has a social security number, it's like your proton number.
Okay.
It identifies the element. Okay? Then when you look at the atom, you can see that there's 17 protons and 17 electrons. Okay, so there's a neutral charge because they're the same. All right, and then we have the 18 neutrons to make up for the mass. When we look at the ion, what do you notice that's different?
The protons and electrons are different.
Correct. Okay, so we have one extra electron, so therefore our chlorine ion has a -1 charge. Okay, good. This is the review stuff.
So, less electrons is positive?
Absolutely, we call those cation ions.
Less is positive.
Less is positive. Yeah, it's kind of opposite. Okay, so less electrons positive, more electrons, you're negative. Okay?
Got it.
Because we can only adjust the electrons, we cannot adjust the protons.
Because then we change the atom.
Absolutely. All right, so now we're going to go into what we call an isotope. Any guesses? Ever heard of that word before? What does the word isotope make you think
The
of?
Simpsons minor league baseball team.
Oh, for real? I've never seen
Seriously.
Simpsons. Oh, I got nothing on
They
that.
have the nuclear facility in the city.
Okay, all right, fair enough. All right, so isotopes, okay, these are going to be atoms that, of course, have the same number of protons, because we said that never changes.
Okay.
But now these are going to have a different weight, so it's a different number of neutrons.
Okay.
Okay, because our mass number is made up of what two particles?
Protons and neutrons.
Yes, so if we have those two in the middle, that makes up all the weight. The electrons are so light that they don't even change the mass. All right. If I change the proton number, I'm working with something completely different. Okay. So we call these isotopes because what we do is we change the neutron number.
Okay.
Okay. So different mass numbers because we have a change in neutron, but it is chemically the same element because the protons and electrons are not changing.
So they're like different versions of the same thing?
Absolutely.
Oh, cool.
I know, it's pretty sweet, right?
Kind of like iPhones?
Yes, like an iPhone 6, an iPhone 7. They're all iPhones. They just have...
But they're just a little different.
A little different, yeah. Good. I like that one. Okay, so here's an example. We got carbon-13 and we have carbon-14. Okay, so down on the left, you'll see that we have the regular old carbon. Everybody's favorite friend, carbon-12. Okay, 6 protons, 6 neutrons. The normal everyday carbon.
Okay.
Then we have carbon-13, and it becomes carbon-13 because what changed? What do you notice?
More neutrons.
More neutrons. Okay, so 6 plus 7 is 13. Just very easy mental math here.
Okay.
Okay, and then we have also an option of carbon-14, and what that is we now have 8 neutrons. So when you see an element with a number after it, it is going to tell you that it is a specific isotope that you're working with. And that's going to change, it's going to what's the word I'm looking for? It's going to tell you. It's not what I was going for, but it'll work. Okay, it's going to tell you the mass number.
Okay,
So you can
the
adjust from
number
there.
afterwards is the mass number,
Correct.
which is protons plus neutrons. Got
And
it.
we can figure out the neutrons because what never changes?
The protons.
Exactly. So I can go to carbon. I know it's 6. I would do 14 minus 6, and I would have 14 minus 6, 8. There it is. There it is.
Geez.
Man, mental block. Okay, so we're going to have 8 neutrons because we just do that simple math. All right. So why do we need to know all of this? Okay. Well, I'm sure your students asked just like mine, Miss K, why is there a decimal? That seems silly. And I told them, oh, get excited. Here it comes. Well, it's here. Okay. So why is there a decimal? Well, it's kind of like a weighted class. All right. So when you have different sections in that class, like maybe let's say your tests are worth 50% and your homework is worth, I don't know, another 25%, and then maybe you have labs that are another 25%. Okay? So they all add up to 100. What they're taking into account here for atomic mass with the decimal is they look at all the different isotopes of that specific element. Pretty simple?
Mm-hmm.
The idea of it, at least, right? So we'd already talked about there's carbon 12, carbon 13, and carbon 14. Okay? So what they do is they average all those together and how abundant they are in the universe. Nature? Natural? Whatever.
Nature.
Same thing. Okay? So, when you calculate this, okay, you can figure out why each element has the average atomic mass that it does by taking the mass number, okay, so carbon 12. You know that it's 12 because 6 and 6 is 12. They say that the abundance is 98.93%, so we're going to change that percentage into a decimal.
Move 2 spots over.
Correct.
I know how to do that one.
Okay, and then what we're going to do is we're going to multiply that by the mass. Okay, so for example, if you did your test average as 50%, you would take 0.5 times whatever your test average is, okay? And then you would add those together, okay? So you would add your test grades, your quiz grades, all of it together, and that's how you would get your average mass. So see how they did the 12 for carbon 12, all right, times its abundance. Then they added the mass of 13 times its abundance. Whoa! Okay, times its abundance, and that's what you'll get you'll add those together, and that's how you get the average.
Got it. So there is way more carbon 12 than there is carbon 13.
Absolutely.
So then the average is much closer
To
12.
Yeah. Seems right?
Sounds good.
Okay, good. Any questions? We'll see you in class.
All right.
Bye.
Guys.